We are in our Chemist Corner this morning, joined by Jesse Miller from the University of Illinois. Good morning.
Good morning.
Fun for the whole family today, huh?
That's right. We're doing a little actual kitchen chemistry this morning.
It.
I know we always say that word, but in this case, it is actual kitchen chemistry. Everything we're using is stuff that you'd have in your home. And this is one of the experiments that we do, like in our outreach program, when we go to the grade schools with the kids, one of the hands-on activities we do with them. And the concept that we're generally using for this, other than just being fun, is surface tension, and we also talk about that milk has fats in it and proteins and things like that.
Okay.
And we'll see that in a very visual way.
Cool.
So what we have here is we just have some plates that I put a little bit of milk in, and you can use just about either 2% or whole milk. I got 2% just because I'm going to drink the rest of this and I don't like whole milk. So, but whole milk actually probably works maybe a little bit better, but they both work pretty good. So 2% or whole milk, because you want that fat that's in there for this to work. And what we're going to do is we're going to put, you guys go ahead and take, I'll start you off, Drew.
Thank you.
You just put like 1 or 2 drops of a couple of the food colorings towards the center. You get a couple, yeah, that's enough. You don't want to get too many. And put more than one color, because it makes it much more fun. And towards the center.
Also towards the center?
Yeah. Now, the reason why the food coloring isn't spreading out too fast is because of the surface tension. Surface tension is that force, you know, even though liquids like water kind of flow, the molecules flow around each other, they still have some sort of bonding, some sort of shape. And that surface tension kind of keeps it. So if you ever see a meniscus, right, where you have the little bubble of water that kind of goes up like that, that is because the surface tension is keeping it in like a droplet. Otherwise, the water would just flatten out. So when you see a droplet on your car from the wax, that's because the surface tension of the water is kind of holding that droplet in place. Okay, so now what we're going to do is we're going to affect that surface tension with soap. Soap is what we call a surfactant, and it reduces the surface tension. So everybody take one of these.
Here you go, Lisa. Thank you.
And
don't put that in your ear, Lisa.
Heat it up first. Okay, we're going to reduce the surface tension. Don't do it yet.
Jumping the gun.
The other thing that it's going to do is that the soap, because soap is bipolar, which means it doesn't mean that
don't call me soap.
It's manic depressive. It's bipolar, meaning that it has both a non-polar end and a polar end. And the polar end is going to react with the fats in the milk, and the non-polar end will dissolve into the water that's in the milk, and you'll see this churning effect from that. Okay, so when you touch it to the center, and it's going to be real fast, you're going to touch it to the center, it's going to break up the surface tension, and then you're going to just hold it there in the center. Go ahead.
Whoa.
Okay.
Cool.
Yeah. Go ahead, everybody who wants to play can play. There we go. Yeah, Lisa's got it. See how it's roiling out from the center?
That's how you do it.
That's where the fatty acids are interacting. What happens is the head of the soap, the polar end of the soap, attaches itself to a fat globule in the milk. Now, milk is homogenized, which means it's been mixed up, so there's tiny little fat globules all over in it. And that's right. It attaches to it and causes the shape to actually change. Okay, the shape of the protein or the fat to actually change, which causes it to move around and do some crazy things. And so this is kind of fun, you know, like you can use different colors, and you can move it around and get some psychedelic stuff going. We call it milk painting.
Get some turbulent eddies
I like
going.
mine.
That's right. That's right. It's very psychedelic.
Yeah. Al, can you turn on that Grateful Dead record over there?
I should have brought the thing to make a lava lamp with. And we could just complete the entire picture here. So this is, like I said, this is an activity. It's a very quick activity. It can be a little bit messy, but you know, it's just milk. So you know, let's not cry over it.
Oh, I was just going to say that. Stole my joke, Jesse.
Sorry, I had that one in my hip pocket for a while. So.
All right.
Since like 70s.
That's right. Excuse me.
Jesse Miller from the U of I, we appreciate it, sir. Hey, try this out with the kids. They'll have a blast. We'll post it on the Illinois homepage later today so you can take another look at it. We'll be right back.